So a car is driving down the road going 30 meters per second. They're about to enter a school zone where the speed limit is only 10 meters per second. What acceleration must the car have to slow down within the 60 meters that it is to get to the school zone up ahead? This is a kinematics problem where you're going to have deceleration. The car is going to be slowing down. So we're going to be writing down our 5 familiar variables: displacement, initial velocity, final velocity, acceleration, and time. We're going to pull our numbers out of the problem and put them in the correct spots. So in this case, the car is driving down the road going 30 meters per second at the beginning of the problem. So that's my initial velocity, a positive 30 meters per second. Now they're going to have to slow down to a speed of 10 meters per second by the time they enter the school zone. So they need to get down to that speed by the end of the problem. So 10 meters per second is my final velocity. It tells us that the school zone is 60 meters away. So that's how far the car is going to travel during the time that it's decelerating. And the question is asking, what acceleration must the car have? So my question mark is acceleration. That means the thing that I don't have and I don't care about is time. So I'm going to pick the equation that does not have time in it. So when I look at my 4 equations, VF squared equals V naught squared plus 2AD is the equation that does not have time, and that's the one I want because time's the thing I don't care about. Now I need to rearrange my equation to solve for acceleration because you see it's way over here. So a lot of people want to do the 2 and the D first. They want to divide that. Don't do that. Remember, when you're doing order of operations backwards for algebra stuff, that's how you rearrange an equation. So when you do your please excuse my dear Aunt Sally is what you're going to start with. That's addition and subtraction. So if you see any addition or subtraction over here, which we have, that's what we're going to do first. We have to get rid of the V naught squared first before we get rid of the 2D. So if I subtract V naught squared from both sides, that'll go away, which is what I'm looking for. I'm trying to get A by itself. And on the left side, that's going to give me VF squared minus V naught squared. And my right side now is just 2AD. Now is the time that I can divide the 2 and the D to get the acceleration by itself. Divide 2D on both sides and see if that's going to leave me with the A all by itself. So finishing up, VF squared minus V naught squared all over 2D is what gives me acceleration. Now we can start plugging in some numbers. VF squared was 10, so 10 meters per second, but we have to square that, minus V naught was 30, so 30 meters per second squared, all over 2 times 60 meters. That's going to give us A. If you have a fancy calculator, TI 89, TI 90, whatever, you could plug this all right in and get an answer. But in case you don't have one of those, you have to do it bit by bit. Here's what that would look like. 10 squared is going to be 100, but I have to square the units too. So that's meters squared over second squared. 30 squared is 900. And again, I have to square my units. So that's meters squared per second squared. And 2 times 60 is 120 meters. And all that still equals A. A 100 meters squared per second squared minus 900 meters squared per second squared is negative 800 meters squared per second squared. And I'm dividing that by 120 meters to get the acceleration. That part I would plug into my calculator and I would get 6.67 negative, because that's a negative 800, meters per second squared. If you're wondering how I got that unit, the meters here cancels that little square there, leaving us with just meters per second squared. So negative 6.67 meters per second squared is the acceleration we have to have. It's negative because your initial velocity is positive and you're slowing down. So the acceleration has to be in the opposite direction. So it makes sense that it's negative. If we got a positive, that actually would have made no sense. So that's how we do that problem.